Testing sound. Mic is working.
Students, wait for like 5 minutes. There's a small technical issue today, so I'm on it. I'm fixing it. So give me 5 minutes. Huh? All right. Let's start. Sorry for the delay because a technical difficulty happened today and we had to switch the camera. So now it's fine. Can you confirm whether I'm audible? Can you confirm whether I'm audible? Students? Anyone? Yes, ne? Okay, thanks. All right then. Now since it's almost 4, we'll be continuing the class until 7 today. Right? Sorry for the delay occurred. All right. Okay, now it's all fine. Yes. Okay, right. Okay. So as we planned last week, we'll be starting Newton's laws today, right? As we planned last week, we'll be starting Newton's laws today. And again, sorry for making you wait because I actually started the meeting at 3:30 and I didn't switch on the camera until you are logging. And today, the usual camera that I'm using is not working. I don't know what the reason is. For some reason, it is not working. So therefore, I had to switch to another camera. And usually I bring another camera to the class and today I didn't bring it. So that's what happened. All right. And I saw some of you were calling me. Yeah, that is what happened. Okay. Yeah, okay. Right. Okay, now it's all fine. Now all fine. Yes. So I think I switched on the mic and I told you that we are going to be like 5-10 minutes late. Right. But somehow when the whole process of switching camera was done, now it took around 20 minutes. Okay. Now it's fine. All right. So we'll start. Okay. What about the other students on YouTube? Let me check that as well. Okay, that is also fine. Right. Okay. Put down the heading as Newton's laws. Then I'll explain what the importance of Newton's laws and what the gravity of the lesson first. Right? Okay. Look at the board and listen. Right. Okay. Listen. So when it comes to Newton's laws in our lineup in mechanics, that plays a huge role. The reason is it is connected to all other parts which are coming up in mechanics and as well in other units. Right? So therefore, when it comes to Newton's laws, it has all the connections, all the links with you are not hearing me from this mic. Give me a second again. Okay, give me 1 second. Right. Now it's fine. Okay. All right. So what I was saying was, when it comes to Newton's laws, listen. When it comes to Newton's laws, the gravity of the lesson is this is not only connected to all other lessons coming up in mechanics. This is also connected to all other units which are coming up in our syllabus. We have 11 units now. From these 11 units, Newton's laws are connected with around 9 units. Right? So that's the gravity of Newton's laws. So therefore, in our syllabus, Newton's laws is playing a major role, and the gravity of the lesson is very much high and that is very impactful, right? Not only for mechanics. So I'm highlighting again, that is not only for mechanics. So that's why Newton's laws is this much important in our syllabus, right? And about Newton's laws, I know you have heard about that in O levels as well, right? But here what we are doing is we are going to more depth with all the types of applications in Newton's laws, and Newton's laws will be followed by linear momentum, right? So both are going together. So today we will be starting the Newton's laws part, and the second half of the Newton's laws will be linear momentum, right? Both parts are very crucial when it comes to our syllabus, right? Okay. Now, let's get started. So when it comes to Newton's laws, how many laws you have heard about? I mean, Newton's laws. How many laws? Any idea? Three, right? Three laws. So there are three laws. Yeah, three, correct. So there are three laws that are introduced, that are actually invented by the great Einstein, the great Isaac Newton, as Newton's laws. And only three means that is only the mechanics laws. Otherwise, when it comes to Newton's laws, there are some other Newton's laws available in other parts of the syllabus as well. They are not the mechanics laws. Here we have three laws, three main laws in mechanics, right? So as the first heading, write down Newton's first law. As the first heading, write down Newton's first law. Newton's first law. Okay, write down Newton's first law. Right. So what do you know about Newton's first law? Oh, try to connect this with, always try to connect this with what you know from O levels. But here some words, some definitions might be different, because in O levels we know it's like a touch and go. So from the surface you are learning about Newton's laws, right? But when it comes to some words, they are used in O levels, and some other like jargon, technical terms we are using in O levels, they might be different from what we are learning in A levels, because in A levels you are learning the 100% exact theorems, right? Not like O levels, right? Because otherwise, if you didn't know the exact meanings of these laws, when we are going to sums, when you are going to questions, applications, we will be stuck, right? So this is not just like applying F equals ma and finding acceleration. Not the case. That is not the case. That is what you have done in O levels. No? Here, that is not going to be the case. So therefore, we'll start from zero, from scratch, and from here onwards, you can compare the things you know from O levels, but there will be some things. Definitely, there are some things. They are actually, since we are going to some depth, they will be different from technical terms we are using basically, right? Okay, first write down Newton's first law, then I'll explain what this first law means, right? Use a red pen and write down Newton's first law. Newton's first law. Write down, if there is no external unbalanced force, if there is no external unbalanced force acting on an object, if there is no external unbalanced force acting on an object, it is either at rest. It is either at rest. It is either at rest, or it is either at rest or moving with a uniform velocity. Either at rest or moving with a uniform velocity. Either at rest or moving with a uniform velocity, right? Right. Look at here. Now, you all have heard about F equals ma, no? Right? You all have heard about F equals ma. F equals ma is not the result of Newton's first law. That is actually the result of Newton's second law. But we can use F equals ma to verify Newton's first law as well. So therefore, before proving F equals ma, now in the next stage, we will be proving F equals ma. So before proving F equals ma, since we have to go with the order as 1, 2, 3, I'll be using F equals ma now to prove this, right? To show this, to verify this first law. Otherwise, you will be seeing the proof of F equals ma in the second law, right? So just be patient for another like 5-10 minutes, because you will be seeing the proof, the derivation of F equals ma through second law as well, right? Look at the board. Now we know one of the main equations, actually the main equation the Newton came up with from second law is F equals ma, right? Here in F equals ma, F represents external unbalanced force. External unbalanced force. Or this is also called unbalanced force. And m is mass of the object. And a is linear acceleration. Right? The reason to say linear acceleration is because you will see other types of accelerations as angular accelerations, rotational accelerations in other coming up parts in mechanics, right? Now, therefore, not like O levels, you can't say just an acceleration, there is a linear acceleration, right? Now, what first law suggests is when there is no external unbalanced force, no, right? If there is no external unbalanced force here, F should be 0, right? If there is no external unbalanced force, F has to be 0. So, therefore, Newton's first law is when F equals 0. Look at here. This is when F equals 0. Now, when F equals 0, what happens from F equals ma is 0 equals ma. 0 equals ma. But when it comes to mass of any object, mass is a non-zero value. Right? Now, we know if left-hand side of the equation becomes 0, then accordingly, right-hand side of the equation should also be 0. Otherwise, it is not going to be an equation. But from these two terms, now we have only two terms to deal with. From these two terms, m is a non-zero term, because even if we consider a tiny particle, it has a weight, it has a mass, right? So therefore, mass of an object is never going to be 0, right? So in reality, we don't have objects without masses. Even if we think of a dust particle, this kind of a dust particle, it has a weight, right? If you are doing chemistry, you know the particle physics behind that, or the particle chemistry part behind that, right? If we consider an atom even, it has a weight, it has a mass, right? So therefore, even if that's a tiny particle in the world, it has a mass. So therefore, from these two terms, which cannot be 0? M cannot be 0, right? From these two terms, M cannot be 0. But M is never going to be 0, right? Therefore, accordingly, to balance this left hand side, A will be 0 and A has to be 0, right? If acceleration of an object is 0, there are two instances the object can have. There are only two instances. One is, you all know acceleration is change of velocity over time. This we discussed starting from linear motion for last 3-4 weeks in the class. Linear acceleration is change of velocity over time, right? This is rate of change of velocity. Change of velocity over time, which means this is a rate of change of velocity. This is a change of velocity. Or we can say that's a difference of velocity. Now, when acceleration is 0, there shouldn't be a difference of velocity, right? If acceleration is 0 from this equation, from the definition of acceleration, if acceleration is 0, delta v has to be 0. Delta v 0 means there is no change in velocity. If there is no change in velocity, there are only two cases, two possible scenarios the object can have. One is it will be at rest, because if there is at rest, there is not a change of velocity because there is no velocity, right? If the object is at rest. So therefore, this should be either at rest or else if there is no change in velocity, if it was a uniform velocity, that is also fine, because if there is a uniform velocity, we have the same velocity throughout, then there is no change of velocity. Final velocity minus initial velocity becomes 0, because both are same, right? So in that scenario also, A is going to be 0. So therefore, uniform velocity is the second possible scenario, right? So this is what Newton suggests from his first law. If there is no external unbalanced force, what happened is it should be either at rest or moving with the uniform velocity, right? So other than these two scenarios, there is no possible scenario for the object to be, right? That is the whole idea, right? Simply, if there is no force acting on the object, if there is no force, that is called the external unbalanced force. If there is no force acting on the object, definitely the object has to be at rest or moving with uniform velocity. Other than these two scenarios, there is no any possible scenario to the object to be. Is that clear? Right? Okay, now start from here. Start from here. Don't write this again. Start from here and prove up to this point. And I'll mention about this somewhere here because acceleration is delta V over T. Right. So start from here and prove up to here. Right. So likewise, using F equals ma, we can verify it. We can verify it. Right? We can verify Newton's first law. Take it down. Take it down. So did you have the class last week? Yes, we had the class. And there's another important notice to be given to you all. That is, from next week onwards, listen, from next week onwards, as the permanent time of this class, we will be shifting this to Friday, right? From next week onwards, listen, this is a very important message. Next week onwards, we'll be shifting the class to Friday, same time from 3:30 to 6:30. Right? This is a very important message. So have a note on this. Otherwise, don't log to the class if you are an online student, or if you are a physical student, don't come to the class on Wednesday, because now as the permanent time here onwards until your A-level exam, the permanent time will be this Fridays from 3:30 to 6:30. Right? So keep that in mind as well. Right? I was planning to tell this at the very beginning, but now with the things happened, I had to rushly make this, change the camera and do them all. So that's why I forgot actually. Then I started the lesson straight away. So just know that from next week onwards, which means the first class you are going to have on Friday will be on next Friday, not this Friday. That will be on 15th. 15th Friday onwards. 15th August onwards. Right? It will be on Fridays, 15th August onwards. 15, yes. It will be on Fridays until your A-level exam on next Friday onwards. Right? 15th Friday onwards. හරනේ පටල ගන්න එපා ඊට පස්සේ එන්න එපා දාදර ක්ලාස් එකට හොඳේ මමත් නෑ මේ මම ඉන්ස්ටිටියුට් එකේ නෑ කොහොමත් ඊට පස්සේ මටත් බෑ right it is on Fridays. All right. Then Newton's second law. As the next heading, write down Newton's second law. Next heading, Newton's second law. Write down Newton's second law. Newton's second law. Newton's second law. Okay, again, first we will write the law and then I'll explain like this. Right? First write the law and use a red pen. Use a red pen and write down the law. The external unbalanced force, the external unbalanced force, the external unbalanced force acting on an object, the external unbalanced force acting on an object, the external unbalanced force acting on an object is directly proportional to the rate of change of linear momentum. The rate of change of linear momentum. The rate of change of, I'll be mentioning here as well if you need, rate of change of linear momentum. Linear momentum. Rate of change of linear momentum. And direction of force. And direction of force. And direction of force is exactly same as, and direction of force is exactly same as the direction of linear momentum. Direction of force is exactly same as the direction of linear momentum. Is exactly same as the direction of linear momentum. Okay, look at here. Look at here. Now, from Newton's second law, this is what he suggests. Now, first law was about when f equals 0. Now, second law is about when f is not equal to 0. Because it says about the external unbalanced force acting on it, right? Which means when f is not equal to 0, right? Now, first scenario was about, or the first law was all about when f is 0, external balance force is 0. But the second law is about what happens if when external balance force acts, which means when f is not equal to 0, right? So therefore, here what comes from the law is this. What comes out from the law is this. This is when f is not equal to 0. This is when f is not equal to 0, right? Now, what Newton says is external unbalanced force acting on an object. Look at the board and listen. External unbalanced force acting on an object, which means f acting on an object is directly proportional to. There is no equation yet, that is a proportionality, right? That is what the law says, directly proportional to rate of change of linear momentum. What is linear momentum? Right, we discussed the equation of linear momentum from units. In units dimensions, also we discussed linear momentum means, so we usually denote it by p, and that is m times v, which means linear momentum is mass into velocity. Linear momentum is the product of mass and velocity. Simple as that. That is called the linear momentum. Right? I know you have this equation also in all levels, but now here also you know this equation from units dimensions as well. Linear momentum, the product of mass into velocity, right? Mass into velocity. This is called the linear momentum. This is called the linear momentum. If there's anyone who don't know what linear momentum is, that is mass into velocity, right? Now, what he says is this force is proportional to the rate of change of linear momentum, right? Anything over time is a rate. Anything over time is a rate. As a very simple example, velocity is rate of change of displacement, right? Change of displacement over time is a velocity. Rate of change of displacement. Any quantity over time is called a rate. Any quantity over time is a rate, right? Now this is about rate of change of linear momentum. Now linear momentum is mv. Then change of linear momentum is delta mv, no? Right? Delta is put for the change. Now rate change of linear momentum should be delta mv. Right? This is for change. This is called delta. Delta symbol, delta means change, right? Then if there is rate of change of linear momentum, this whole thing over time, right? Because anything over time is a rate. If I need the rate of change of linear momentum, this is the change of linear momentum. And if that's over time, that is the rate of change of linear momentum, right? Okay, now if I expand these terms, look at the board. Look at the board. I'm going to expand this. I'm going to expand this. Delta mv can be written as final momentum minus initial linear momentum. If I consider v as the final velocity, right? For the same object, mass times final velocity will be final linear momentum, right? And that same mass times initial velocity will be initial linear momentum, right? Then if this is final linear momentum and if this is initial linear momentum, the change of momentum should be final linear momentum minus initial linear momentum. Clear? Over time. Now, since m is common, I'm going to take it out. See, then v minus u over t remains. This is something we know. What is v minus u over t? Final velocity minus initial velocity over time. There is acceleration. Right? So you all know by now, you all know that v equals u plus at. Now, if you subject acceleration from here, acceleration is v minus u over t, right? Change of velocity over time, that is an acceleration. So therefore, if v is proportional to m, this part can be replaced as acceleration. Proportional to ma now, right? Now hereafter, what Newton did was this. Hereafter, he did several researches on this relationship, because now if we have a relationship like this without an equation, we have to find a proportionate constant to make this an equation, right? So, you know what we are using in dimensional analysis as the proportionate constant, k, right? So that k should be determined. For that, Newton conducted a series of researches, and finally he came up with something like this. Now, initial conversion is, this has to be written as F equals Kma by considering K as proportionate constant, or this is called proportional constant. Proportionate constant. Or this is also called proportional constant, right? If we need to convert a proportional sign into an equation, we have to use a proportionate constant. Now, in this case, now he assumed it as k first, and then after that series of researches he conducted, he found that k is always going to be 1 if mass is plugged in terms of kilograms, right? K is always equal to 1 if and only if the mass is plugged in kilograms, right? So therefore, finally he stated the final equation as F equals ma, making k equals 1, and it's a must, it's mandatory to plug mass in kilograms, right? If we use grams, k is going to be having a value other than 1, right? ඒකට value එකක් තියෙනවා. ඉතින් ඒ value එක හොයලා නැහැ. 1 ඕනේ නැහැ. අපිට ඕනම gram or milligram or whatever it is, we can convert it to kilograms and we can use in the equation. No? Otherwise, if we are going to have different values for k, it is not going to work. So therefore, Newton came up with the equation as this. He stated the equation as F equals ma by making k1, by finding k as 1. We will be writing this on the note, in the note, making k1, because if mass is subjected, if the mass is substituted only in terms of kilograms, that becomes 1, right? So therefore, it's a must to use kilograms when you are using F equals ma, right? So unlike other equations, it is not going to cancel from the other side. So therefore, it's a must to use kilograms, right? Okay, now start from here and first prove up to this point, right? Prove up to this point. This is the proof of F equals ma through Newton's second law, right? So as I told you, that's why I told you now, even though F equals ma is the result of, that's a conclusion of Newton's second law, we can use the same equation to verify Newton's first law as well, right? second law එකම use කරලා first law එක හරි කියලා පෙන්නන්නත් පුළුවන්. and third law එකට එන්නත් ඕකම තමයි. right? ඒ එකම equation එක laws තුනටම connect වෙනවා. It's going to be connected with all three laws, and we can verify using F equals ma. Right? Okay. Start from here and take it down up to this point. I won't be able to join on Fridays. Is there any other? As the other date, what I have is the new batch date. New batch is going on Tuesdays from 7 to 10. Tuesdays from 7 p.m. to, not morning, new batch is on Tuesdays from 7 p.m. to 10 p.m. And there are, next week, we are starting measuring instruments, right? So that is the batch start after all is also. So therefore, it's going a little bit with a delay, I mean, a little bit behind with a delay, because that is only 3 days we have conducted that class. Yeah, that's the other option you have. Who asked that question? Zaid. Yeah. Prove up to this point. Right, and write down the equation again and highlight this equation. We are going to introduce terms properly here. Write down the equation again and highlight the equation, and we are going to introduce these terms properly here. Right? F. What is F? The exact name is external unbalanced force. For force, no marks are given. Right? O levels allam force kiwat denawa. Me A levels allam denne naha, okay? Because there are different types of forces when it comes to forces. Right? This is only the external unbalanced force. Right? So exact name is external unbalanced force. Write down F, external unbalanced force. External unbalanced force. M is mass. A, linear acceleration. So as I told you before, don't write just acceleration. Now, for this part of mechanics, for Newton's laws of mechanics, that will be only about linear accelerations, right? But when we are moving on, even in mechanics, the other lessons are coming up as rotational motion, angular motion. There you will see what other types of accelerations are. So therefore, to be exact, this has to be linear acceleration. This has to be linear acceleration, right? Okay. Now, again, mention this point with the red pen, put an asterisk mark and mention this point. Mention this point. After the class. Write down as long as simple m is substituted, as long as simple m is substituted, as long as simple m is substituted in terms of kilograms, in terms of kilograms, kg, yeah? Simple K, simple G. As long as simple m is substituted in terms of kilograms. Value of proportionate constant, value of proportionate constant, value of proportionate constant K equals 1. Value of proportionate constant K equals 1. Value of proportionate constant K equals 1. Right? So that's the argument behind, that was the logic behind K becoming 1. So that is why we can use the equation as F equals ma without using it as F equals Kma. Right? So that is how the introduction of F equals ma was done. Right. So before moving on to the third law is very easy here. Before moving on to the third law, tell me if there are any questions up to this point, because this is the major and the most important law that you need to understand other two. Right? Make a connect. So that's why I'm emphasizing on this much. So ask me if you have any questions about the things we covered up to this point. All good? Any questions? If you have any questions, please ask. Online students? Online students? What about you? All clear. Good. So what about students on YouTube? What about you? So I can see both chat boxes. So if you got any questions, doesn't matter whether you are on Zoom or YouTube today, you can forward your questions to the chat box, then I can see, right? So that doesn't matter. Right. Okay. Then if there are no questions, let's move on to the third. Next heading, Newton's third law. 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 So this is the most popular one. So I know all of you know this. Right? What is Newton's third law? The most popular one. Huh? No. Huh? What is the third law? On lessons? If I say, there are a few questions also coming up. I didn't see. Let me answer them first. Yeah, the correct answer is also the reaction as opposite reaction. That is actually should be equal and opposite. And okay, let me answer these questions first. So if M and A increases, then F also increases. Yes. If M and A increases, yeah. So if increase, then F also M and yeah, same thing, right? And I saw another question. Yeah, this one. So I have doubts regarding constant. Is constant means always dimensionless, or will they provide in equation as the constant have dimensions? I'm getting confused when I'm practicing questions. Listen, constants are not always dimensionless. There are constants with dimensions and without dimensions as well, right? If there is a constant with dimensions in dimensional analysis like parts, you will be given that dimension, right? Now, as an example, see, I don't think you know this equation, but I'll be using this equation to explain about that question you asked. This is called universal gravitational constant. That is also constant, but this constant has dimensions. So therefore, constants are not always going to be dimensionless. But if that constant is a number, that is going to be dimensionless, because numbers are dimensionless. right? There are only 5 scenarios we have as dimensionless occasions, right? So I discussed in the new batch class yesterday, right? What are the 5 dimensionless scenarios? Numbers, angles, trigonometric ratios, logarithms, and integers, right? Constants කියලා එකක් නැහැ, right? Constant කියලා එකක් එදන්නේ නැහැ. If that constant is a number, now in this case, k was a number, 1. That's a number. So therefore, it's dimensionless, right? So I hope it's clear now. All right. So let's get back to the lesson. Yeah. So you are correct. Third law is the most popular one, right? Okay. First, write it down with the red pen. Write it down with a red pen. Every action has a reaction, right? Every action has a reaction. Every action has a reaction. Every action has a reaction which is equal in magnitude. Which is equal in magnitude. Which is equal in magnitude and opposite in direction. Which is equal in magnitude and opposite in directions. So likewise, as they asked, if you got any doubts regarding anything, you can forward your questions and get it clarified if needed. Yeah, they were good questions. And I'm always happy to answer your questions because now asking a question means you will understand it better once it is sorted. That's the thing, right? Sometimes you might have made a mistake or there might be something. So if that's a mistake or anything, at the end of the day, what you have is a learning, right? So therefore, you won't be forgetting it again. So that's it. That's actually the advantage of asking questions and getting them clarified. All right. So the idea of this is like this. Reaction forces are, listen, reaction forces are mainly due to the contact, right? Reaction forces are due to contact. If there are two surfaces which are in contact like this, now let's say these two, now these two surfaces are in contact now, right? So in between these two objects, there will be reactions, right? And one of the force will be the action force and the other force is going to be the reaction force. Otherwise, I can't say the force on the blue pen is action and the other is reaction, or on the red one is action and other one reaction. No. When we say one force has action, the other one becomes reaction, right? There are few things to know about marking these reaction forces. So therefore, first we will see how these reaction forces are marked, and let's move to the other part coming up, right? So now just have the idea that about the third law, what Newton says in its third law is that is about action and reaction forces. And action and reaction forces are always if there is a contact, right? There's a contact means there should be minimum two objects which are in contact at the same time, right? Minimum two or more than that, right? Now, if this blue pen is in contact with both of them, then there will be two reactions. So likewise, if there is a contact, there will be a reaction, right? Okay, as the next heading write down, marking reaction forces on objects. 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 Okay. Look at the board. Look at the board. I'm going to consider two random objects which are in contact like this. And as a standard, even though they are in contact, to separate forces, as a standard, when drawing force diagrams, or that is also called free body diagrams, we are keeping a small space in between in the diagram, right? So in reality, they are actually in contact, but to separate forces easily, about like which force belongs to which, as a standard, we are keeping a small space here, right? Otherwise, this is actually in contact. This is actually in contact. right? This is how reactions are going to be marked. Now this point is going to be the contact point now, right? Before marking any reaction, we have to have something called a common interface. A common interface. Common interface is the interface which goes through both of the objects, and this shouldn't be intersecting any of the objects, right? මෙහෙම common interface එකක් තියෙන්නේ. Common interface is always going through the contacting surface without intersecting any of the objects, right? This is called the common surface. Common surface. This is called the common surface, right? And reaction forces are going to be perpendicular to common surface. Reaction forces are going to be perpendicular to common surface. So that's the importance of knowing what the common surface is, right? Otherwise you can't mark these reaction forces as you wish, right? Then their directions may be different. Definitely they are going to be different. So therefore first you have to have an idea about what the common surface is, and with respect to that common surface they will be perpendicular, right? And when it comes to reactions, look at here, they are exerting like this. Now let's say this object is going to be in contact with this, right? Now with respect to this palm, this is in contact from this side, so therefore tendency of this is to move to left side. So which means the reaction is going to be exerted towards that particular direction. If we think of the contact with respect to this, now this is in contact with this, with the knuckle from this side, then this tendency is going to be to the right. That is how the direction of reaction forces are determined. Now look at here. Now with respect to this object, this is going to be in contact with the other one from this side, so that moving tendency is to the right. So therefore reaction on this one is to the right, like this, and that is perpendicular to that common surface. And reaction on this one from this is going to be to the left, right? And that will be at here to the left direction. And these two are equal and opposite. That is what Newton suggests in his third law, right? And when one force is an action force, the other one becomes the reaction force, right? අපි AR කියලා දාන්නේ, right? From both reactions, one is action and the other one is reaction, right? We can't separate action and reaction because both exerts at the very same time, at the same time. Then contact වෙනවා කියන්නේ both are going to be in contact at the same time. So therefore both forces are going to be exerted at the same time, right? If we say this as action, this becomes a reaction, and if this is action, this becomes a reaction. So this is called an action-reaction pair. This is called an action-reaction pair. Clear? Right? So this is the basic behind marking reactions. This is the basic behind marking reactions, right? So after this, we'll see how you are going to mark reaction forces in some example scenarios given, right? Okay, take this down. Take this down. Now, if you have learned something about marking weights, reactions, actions, or any other thing in O levels, forget all of them and delete all of them from your head for a moment, right? Because I know, and I have met students in like other years as well, past years also. Now sometimes in your head you have something that is coming from O levels, and that's a wrong idea. Now if you have that wrong idea in your head about weight about weights and reactions, completely forget it out from your mind for a moment now until I explain the other cases, and then you will get it clarified after the explanation, right? ඒ වගේ පොඩි cases තියෙනවා. මොකද O levels වල අර touch and go එකක් ඉඳලා A levels වලට ආවට පස්සේ පොඩි gaps තියෙන තැන් තියෙනවා. This is actually one of the places, right? In maths you will see more gaps in combined maths and O level maths, right? All right. Below this, mention this point with a red pen. Mention this point with a red pen. Put an asterisk mark and mention. Put an asterisk mark and mention this point. always reaction forces are perpendicular to the common surface. Always reaction forces are perpendicular to the common surface. Always reaction forces are perpendicular to the common surface. Always reaction forces are perpendicular to the common surface. And common surface should not be intersecting, and common surface should not be intersecting, and common surface should not be intersecting, and common surface should not be intersecting any of the objects, and common surface should not be intersecting any of the objects. All right. Okay, as an example, take this down. Now we are going to discuss about few examples. As an example, write this down. Write down. Mark all reaction forces. Mark all reaction forces. Mark all reaction forces. Mark all reaction forces. Mark all reaction forces acting on objects in given scenarios below. Acting on objects in given scenarios below. Acting on objects in given scenarios below. All right. Look at here. I'll do the first one for you, and then I'll let you try the coming up ones. Right? From number 1. This is a block. Let's say a wooden block kept on a surface. Right? This is a wooden block kept on a surface like this. Right? Now, as an example, something like this. Right? Assume this as a wooden block. This wooden block is kept on the surface like this. Right? Now, as I told you, even though there is a contact here, we'll be keeping some space in between to easily separate these forces, to easily distinguish these forces. Whether this one belongs to this one or the other one is going to be this one. Right? That's the thing. So therefore, as a standard, you will follow the same in combined maths as well, and in physics also. That's a rule of thumb, not a rule, but a rule of thumb. And you also see when we can easily separate forces only, we can identify forces easily. So therefore, that is for our own advantage, own benefit, right? So the scenario is like this. This is a horizontal surface, and on the horizontal surface, this block is placed, right? And one of the main points most of you might go wrong is weight is not a reaction. Sometimes weight reaction weight is not a reaction. Forget about the weight, right? I'm not asking you to mark weights here. We are not going to mark weights here. We are going to mark only the reaction forces, and reaction forces are the forces which exerts due to the contact, right? Now there's a contact between these two. This is the floor and this is the object. At this surface, there's a contact between these two, right? Now, if you think of the common surface has to be going through the contacting surface without intersecting any surface, any object, right? So this is the common surface for this case, right? Now, since you are practicing marking reaction forces here, it's actually advised and recommended to mark common surface and mark forces. But when we are moving on, what we are doing is, when you master this, first day you are not going to master this skill, no. When you master this, what we do is, we'll be imagining where the common surface is, and perpendicular to that imagined common surface, we'll be marking forces straight away, right? But for today, what I recommend is to you to draw the common surface and mark, right? Otherwise, we are not going to mark the common surface in the coming up questions and everywhere. But here, I'll be marking the common surface for your understanding, right? When you fine tune this skill, you can just imagine where the common surface is and mark reaction forces at once. Right? Okay, now this is the common surface now. Now, if we think of the block, wooden block is in contact by the flow with the flow from the bottom, like this. So the reaction on the wooden block is, what is the reaction? Upwards, right? Contacting from the bottom, right? That is upwards. So we'll be marking it on that block only, right? Right? But actually, to separate between these two, contact like this. So let's say R, right? An equal and opposite reaction of this will be on the flow. On the flow, make a ground or flow on the flow. And with respect to the flow, the block is in contact from the top, right? And that block is in contact from the top, no? So that is exerting the reaction downwards. Right? Equal and opposite. Now, if you have marked one force, definitely the other one is going to be equal and opposite. That is true. But what I explain is how that exerts, because the block is going to be in contact from the top surface like this. So the reaction is downwards. So that is equal and opposite on ground. Right? This is how we mark reactions. This is a simple example scenario. Right? Understood? All good? Online students, any questions? Are there any questions? So can you repeat, please? You mean what? Can you explain again? You're asking about what? Right. So if you understood, you can take this down, and I'll give you a second scenario now. Right. Take this down, and try this second scenario by your own. Try this second scenario by your own. And if you can see different reactions in terms of values, you have to use R1, R2, R3, likewise different terms. If you can see them as different reactions, don't use same R. If they are different in terms of the value, use R1, R2, or so on and so on. And if you have finished the first one, you can start the second scenario. So can you explain the first scenario again? This one. First scenario. Look at here. Now, this is a scenario where a wooden block is kept on a horizontal surface. Right? Horizontal surface. Now, as I told you, we'll be keeping a small space in between to easily separate these forces. Right? So that's why I have kept this space here. Right? And we know this common surface should be going through the contacting surface without intersecting any of the objects. Right? This is the common surface. So the respective common surface according to the scenario here is going through this contacting surface without intersecting none of them. Right? Without intersecting any of them. Right? And with respect to the contact, now contact is like this. One is at the top and the other one is at the bottom. Flow is at the bottom and the block is at the top. So flow is in contact with the box from the bottom. So therefore, that tendency is to upwards. Right? It's like pushing from behind. Right? The similar idea. When the flow is at here, so it is pushing upwards. So therefore, the reaction exerts upwards. And if you think with respect to the wooden box is pushing the flow downwards. Right? Contact and reaction right? When that is in contact from the top, that is pushing downwards. So therefore, reaction is going to be downwards. Right? So I hope it's clear. If not, you can ask again. Right? Madhi. And if it's clear enough, you can start the second scenario. If it's clear enough, start the second scenario. Clear. Okay, good. What about the second one? Now, if you have different reactions, different in the sense, different in terms of their values. If you have different reactions, use different notations, different labeling. No? Notations in the sense, different labeling. Yeah, correct. Good. Correct. Right. So there is one contact here. There is one contact between these two here. Right. For your understanding, I'll be labeling this as A and B. Right. So there are two objects as A and B. One is kept on the other. Right. So for the reaction between A and B, right? For the reaction between A and B, the reaction on A from B will be, that is hitting from the behind, hitting from the bottom, not the behind, bottom actually, hitting from the bottom. So this will be upwards. I'll be considering it as R1. And the equal opposite reaction of that will be on B downwards at the same surface as R1. And just know that action reaction pairs are not going to be in two different surfaces. That is at the same surface. That is actually called a mutual surface because there are two objects which are in contact. So that's a mutual surface, right? Reaction of this force is never going to be on a surface like this. That is not a mutual surface. For these two objects, the mutual surface is this. For B and flow, mutual surface is here, right? Then second contact is at this point. Second contact is here. Then from the ground, from the flow, it will be upwards on B like this. Value is different. So I'll be marking it as R2. And equal and opposite reaction will be on the ground as R2. Right? Understood? Third scenario. Third scenario. Third scenario. This is a cylinder kept on ground like this. A cylinder kept on ground like this. And a rod is in contact with the cylinder like this. A rod. A rod is in contact with the cylinder like this. Right? So it is like, assume this as a cylinder, right? This cylinder is kept on the ground. And what I have given you is a side elevation. This is what you see from this side, right? Cylinder එකක් තියෙන්නේ. This is the center. This is a cylinder, right? This is a cylinder. This is a cylinder, right? This will be the side elevation. And for that cylinder, another rod is kept in contact like this, right? It can be kept like this, practically, naturally. That's the scenario. Okay, try it. Try it. And if you got any questions, please ask. Right? How many contacts are here? How many mutual contacts in this scenario? Three. Three mutual contacts are there, right? Three. Yeah, three. Okay, finished? Finished? So any questions? Any questions from online students? Or is it all clear? Okay, let's check this. Okay, there are three contacting surfaces. There are three contacting surfaces here. Three mutual contacts here. One contact is at this point. So at this point, this is a mutual contact, right? So there will be a reaction, and in terms of geometry, I know you know this, even if you don't draw it here, right? If we draw a normal line, a perpendicular line to the circumference of a circle, it goes to center, right? So that's also there. So therefore, I'll be drawing this as it intersects the center, R1, because actually it intersects the center, right? Sometimes those geometries also needed for our calculations, as triangles and all that, to determine angles or whatever, we need triangles. So therefore, if we have this kind of a geometry, you better mark it with that geometry as well. So R1 and R1, right? And here, this is another mutual contact, and common surface is like this. It should be parallel to the rod. It should be parallel to the rod, right? And at the contacting point, the reaction will be parallel to this, like this, R2, and this reaction which is on the cylinder will again go through the center, R2, right? It will again go through the center. And we have another contact here. Common surface should be like this, right? Contact of rod with the flow. And let's say the reaction is R3, so that will be on rod upwards as R3 and on ground downwards as R3, right? Okay, next. Ask and clarify if you got any doubts about marking reaction forces, because this is one of the vital things, very much important, crucial things we need when it comes to problem solving in coming up parts, right? Okay, this scenario, this is an inclined plane, right? So on this inclined plane, two objects are kept like this, and these two are also in contact. So let's say A and B for our ease of identification, right? So they are like this. They are kept on the surface like this, and they are also in contact, right? Right? Questions? Can you clarify the third one again? You mean R3 or third scenario? Third scenario. First, identify how many mutual contacts are here, right? When you are marking reactions in any of the applications given, right? First, identify how many contacting surfaces are there. According to the number of contacting surfaces, there will be reactions, right? So one contacting surface is here, the contact between cylinder and the flow, and if this is the common surface is not intersecting any of the objects. So if this is a common surface, reactions are perpendicular with the common surface. So for this common surface, it is R1 and R1, this pair. I have marked that pair with respect to the common surface or the contact here. And there is another contact between cylinder and rod here, cylinder and rod. I said you, these are rod, these are rod, right? So there's another contact here with cylinder and the rod, right? And that common interface should be like this. Otherwise, if you let's say you are trying to draw a vertical or horizontal common interface, definitely it is intersecting the objects. Then there is not going to be a common interface, common surface. So that's why I told you common interface is not intersecting any of the objects, right? Then for this common interface, the reaction should be again perpendicular. So I have marked that pair as R2 and R2. right? And the third mutual contact is here, the rod with the flow, and common surface is going through two surfaces like this, and from the flow, the reaction on rod is upwards. Flow is hitting with the bottom, and the rod is hitting the ground, hitting the flow from top. So that reaction is downwards. I consider that pair as R3. Now these three pairs are separately following Newton's third law. Separately, yeah? As pairs, they follow Newton's third law, right? There are three pairs here. Three pairs. Understood? Finished? Yeah, correct. Correct. Okay. First, understand how many contacts are here. One contact is the contact of A with inclined plane. This is an inclined plane. No? First contact is the contact of A with inclined plane. So the common surface between A and that plane is here, right? This reaction has to be on A like this, let's say R1, and on plane like this R1. And the second contact is B with the inclined plane. So the common surface is in between B and plane, and it goes like R2 and R2. And there's the third contact as well, because A is in contact with B, right? A is in contact with B. So this is the common surface which goes through the contact surface of A and B, right? Then that reaction will be, now A is hitting from this side, then on B, that is to this side. That is R3. And on A, V is hitting from this side. On A, that is to this side, R3. This is how it should be marked, right? Next scenario, what's the number 5? Number 5. This is a vertical wall, and this is a horizontal ground, right? And this is a ladder. This ladder is kept in equilibrium in between a vertical wall and a horizontal wall, right? So that's a practical scenario. We can keep a ladder like this in between two vertical and horizontal surfaces, right? So that's the scenario given. That's the scenario given. Right? A and B has the same common surface. No, different. They are acting in the same line. That doesn't mean that's the same common surface, right? That is not the same common surface, but acting along the same line. Acting along the same line. Right. Right. So there are two common surfaces here, two contacts, two mutual contacts. If there are two mutual contacts, there should be two common surfaces. One contact is the ladder with the vertical wall. Ladder with the vertical wall. So the common surface is going through this contact like this. So the reaction on ladder from wall is to the right, as let's say R1. That will be perpendicular to this, and this will be the equal and opposite reaction on wall. And we have the second contact here, bottom of the ladder with horizontal wall with horizontal surface, right? So flow is hitting with the ladder from bottom. So this reaction, equal and opposite reaction will be on flow like R2, right? All right. Any questions up to this point? Any questions up to this point? All clear? Right? Online students? What about you? Any questions? Clear? No. Clear. Okay. Right. So let's move on. As the next heading, write down tensions on strings. Tensions on strings. Next heading, tensions on strings. Tensions on strings. Tensions on strings. Right. Listen. Listen. Now this is a string. See? So assume this has a string. This is a string. Right? If the string is stretched, now after some point it will be stretched. No? Now this is not stretched. This string is not stretched. But if I apply two forces like this, that will be stretched. Right? The string is stretched. If a string is stretched, tension forces are exerted on the string. Right? If there is loosened like this, if the string is released, no tension forces. Tension is zero. Tension is zero. If there's a stretch, there will be tension. If there's no stretch, there's no tension. Tension forces are a special type of reaction forces which occurs due to stretch of the material. Stretch, or we call the extension of the material, or the stretch of the material. Right? Now, due to tension forces, see, this one is like tight, no? This is tight, like this is stretched. So therefore, to make it tight like this, the tension forces has to be, see, if I say this is a string, right? If we have tension forces like this only, it will be stretched. Like this only, it will be stretched. Right? Otherwise, if we have forces on the string like this, these two forces are attracting to each other. No? So this is going to be loosened. Right? So therefore, no tension forces acting like this on strings. Right? Tension on string will always be in opposite directions. Tension on string will always be in opposite directions because tension forces cause the string to stretch. Right? The stretch maybe the forces to make a stretch, right? It should be like repulsive forces in opposite directions. Right? So that is how tension forces exert on a string. Right? On a string, I'm highlighting again on a string because it is going to be different on an object. On the string, that is like this. On objects, that will be different. That is the next step we are going to see. Right. First, write this down. First, take this down. Take this down. Take this down. Take this down and mark tensions as T and T. T and T. Mark tensions as T and T. Right? Okay. Below that, mention this point. Mention this. Tension forces are tension forces are tension forces are tension forces are exerted tension forces are exerted tension forces are exerted on strings due to stretch of string, due to stretch of string, due to stretch of string, due to stretch of a string. Second point, tension becomes zero, tension becomes zero, tension becomes zero, tension becomes zero. If there's tension becomes zero, if there's tension becomes zero, if there's no stretch on the string, if there's no stretch on the string. Right. Now, mention these 2 points with a red pen. Put an asterisk mark and mention this point in red. If a string is weightless, if a string is weightless, if a string is weightless, if a string is weightless and inelastic, if a string is weightless and inelastic, what's the idea of inelastic? What is meant by elastic? Stretchable, right? Stretchable. Inelastic means there's no chance to stretch, right? Stretching in the sense the substance or the material, the particles should get stretched, like rubber bands. So they are the elastic material, right? Now what I showed you was an inelastic one. Rubber band stretch, that's called the elastic property, right? In reality, listen, in reality, we don't have weightless strings, right? In reality, I told you at the beginning of the lesson also, I told you there are no objects without masses, right? So in reality, even for a tiny string, it has a mass. But for our calculations, we'll be having 2 types as weightless and weighted strings, right? That is just for calculation purpose. But for A-level physics, most of the calculations you will be getting will be from weightless strings, right? Most. But we have the weighted cases as well in the last part towards the latter parts of Newton's laws, right? Okay. What did I say? If a string is weightless and inelastic, tension on string, tension, let's say of string, tension of string at any point is same. Tension of string at any point, tension of string at any point is same. Tension of string at any point is same. Right? Next point, keep using the red pen. If a string is weighted, if a string is weighted and elastic, if a string is weighted and elastic, tension of string is different from point to point. Tension of string is different from point to point. Tension of string is different from point to point. Okay, right. Weightless, don't write. Just look at here. Weightless and inelastic. Strings are also called ideal strings. Right? Any ideal scenarios are not existing. That you know, ideal gases, ideal capacitors, ideal resistors, ideal voltmeters, ideal strings here. Right? Ideal cases are hypothetical scenarios. Right? But for calculations, we will be doing calculations with ideal scenarios. But in reality, in real world, we don't have ideal scenarios in reality. One of the best example is ideal gases. Even though you use PV equals nRT for calculations of ideal gases, right? You haven't started gases yet, ne? Started? No, no. You are not doing chemistry. I did it. Chemistry. You might see in the coming parts in chemistry, right? We'll be doing calculations using PV equals nRT, but there are no gases as ideal gases in reality, right? They are just hypothetical scenarios. There are closed scenarios, but there are no 100% ideal gases, right? So here also it's like that. So as the next point mentioned, use the normal color, not red. Use the normal color and mention this point. Weightless inelastic strings are called weightless inelastic strings are called ideal strings. Weightless inelastic strings are called ideal strings. Weightless inelastic strings are called ideal strings. Okay. Now stop all your work and look at the board. Right? So about tensions, this is the cream that you need to understand. This is the core, this is the cream that you need to understand. Right here. Let's assume we have two objects. Let's say A and B. We have two objects as A and B. We have two objects as A and B. Right? And these two are connected with a string like this. These two are connected with a string like this. And I'm going to apply a force, external force, capital F, towards this direction. Right? Now, when we drag this system with this force, look at the board. When we drag this system from this force, now since this is attached to A is also going to move. Right? So when it moves, the string is also moving and the string will be stretched. Right? So if I apply the force towards this side, the string is going to be released, right? But if I apply this force, this direction, which means the drag, if I drag towards this direction, the string is going to be stretched, which means there should be tension forces exerting on this string, right? On the string. If a string is stretched, tension forces on the string will be, right? We draw this before as well. Tension forces on the string will be like this. The tension is, if the string is stretched, tension forces on strings is going to be like this, right? These are the tension forces on strings. For your clarity, these two are the tensions on a string. Tensions on strings, right? Now, according to Newton's third law, right? Every action has an equal and opposite reaction, right? Tension forces are also a special type of reaction forces, right? So therefore, the equal and opposite reaction of this tension has to be on the mutual surface or the mutual object, right? Now, if I think of this tension is actually on a string. On a string means it is created by someone else, right? Own reactions cannot be, or reaction on one object cannot be like self-exerted. Reaction should be exerted by someone else. Now, in previous 5 scenarios I took, you can clearly see it. Reaction on A will be due to B. Reaction on B is due to A. So likewise, they are mutual. Thaniyeng reaction එකක් හදාගන්න බෑනේ. Right? There are no reactions like self-exerted. No. Always a reaction is exerted due to someone else. Right? Now in all previous scenarios you can see, right? Flow එකකින් හරි වෙන කවුරු හරි object එකකින් හරි rod එකකින් හරි මොකකින් හරි තමයි reaction එක හදලා දුන්නේ. It was exerted, it was created due to someone else. That's a third party. Third party කියලා කියන්නේ someone not relevant to the same body. Same එක්කෙනාට බෑ. A's reaction will be due to someone outside A. Something like that. Right? So tensions are also like that. Listen, now if this tension is created on string, now this is the tension at this end of the string. This end is connected to A, which means this tension should be due to A. That is actually due to A. That is actually due to A. So similarly, according to Newton's third law, the reaction force of this tension should be on A. Is it clear? Now, if this contacting point is A and the string, if this contacting point is A with string, now this is the tension on the string. It is created by A. Then opposite should be on A created by the string, right? Reaction and that reaction will be on A. That reaction will be on A at the same point. That I will be marking here to the opposite direction, right? Like this. So similarly, at this point also, there will be another tension on B at the same point like this, right? So if we mark it here, since it is not clear, I have marked it at this point, but actually the tension is at the very end point, right? That's not going to be an issue because tension throughout is same that I mentioned. In a weightless inelastic string, tension is going to be same throughout, right? And these two are called, you should be very clear on these tensions. These two are called tensions on objects. These are tensions on objects. Tensions on objects, right? May string again, may the string should be released. It should be losing the stretch, right? On the string, they are to the opposite directions. Then on the objects, to the opposite directions of these pairs. So therefore, these two is the pair which follows what? Newton's third law. This pair follows Newton's third law. Follows Newton's third law. Similarly, this pair again follows Newton's third law. Right? So clearly explaining from here onwards, because most of the students I have seen, they are thinking that these two are going to be following Newton's third law. No. Because always, if two forces, if a pair of forces following Newton's third law, there should be mutual objects and a mutual contact. Right? So this is where the mutual contact is. A with the string and string with A. This is string with B and B with string. Right? Right? I'll introduce these tensions as well. I'll introduce these tension forces as well. Like this. See, for your clarity, if I introduce this tension is tension on who? Tension on A. This is tension on A by string. Tension on A by string. Right? And this one, let me erase this part. And this one, this is very much important for our proceedings. And this one is tension on string by A. String by A. So that is why these two are mutual. On string by A, on A by string. They are mutual. This one, tension on string by B. And this is tension on B by string. Right? So this is how these four tensions are identified. Right? You should be 100% clear about these tensions, about marking these tensions after this point onwards, because we are going to move to sums in a very short while, and this identification of forces is mandatory when we are applying F equals ma. Right? And just listen, the reason to mark tensions on string separately is, now if we mark it on the same point, at the same point to the opposite direction, that is kind of messing. That is why. And the other reason is, we are not going to use any equations for strings in this part, because the string will be weightless. Since the string is weightless, no point of using F equals ma to string. M becomes 0. When M becomes 0, F is 0 anyway. So therefore, we will be sticking to tensions on objects with the questions. But you have to know that the equal and opposite tensions on strings is at the same point to the opposite directions. Right? So we don't mark this usually on our force diagrams, right? If there's a even if there's a if there's a special requirement, only we'll be marking this. Unless otherwise, we don't mark it. We'll be always marking the tensions on objects because we will be applying the equations only for objects. No point of applying the equation for string if that is weightless, right? But when it comes to weighted strings, that is also used. But for the first part of Newton's laws, you are going to deal with all weightless strings. So therefore, we will be sticking to tension on object only, right? But you should know this. When we are at weighted strings, if I ask about the tensions on the strings, right, then you can't be like, you haven't heard it before, right? So that's why I'm explaining this from the beginning. Is it clear everything about this diagram? Right? Online students. What about you? If this is understood about tensions, you are perfectly fine to go. Right? මේ ගොඩක් කට්ටිය ටෙන්ෂන්ස් වල මේ පටල ගන්න දණක් මේක. හරි. Basics ටික හරියට දන්න ඕන. Basics in the sense the fundamentals, fundamental concepts, the basic concepts are known. When we are moving towards advanced questions also, they are easily doable, right? Otherwise, if you didn't do basics, if you didn't know basics properly, definitely you get stuck when you are at like advanced or average questions, right? Okay, online students, what about you? Quickly. Is it clear enough? Or if you have any questions, please ask quickly. Understood. Okay, good. So if you can't type, at least put a thumbs up reaction on Zoom. Reactions are available, no? Right. Okay. Take it down. So if you are using different colors, you can use different colors to show these pairs properly and take it down. Right. That is as you prefer. If there are different colors, if you have different colors, use them and draw it clearly. Draw it clearly. චූටි diagram එකක් අඳගන්න එපා. ඊට පස්සේ mark කරන්න ඊටමදි වෙයි. Have kind of a large diagram to mark all of them properly. To mark everything properly. Right. Finished? All right. So mention below with an asterisk mark, mention this below. Usually tensions on objects will only be marked in force diagrams. Usually tensions on objects will only be marked in force diagrams. Second point, but tensions on string, or say strings, but tensions on strings at the same point, at the same point, in opposite direction on the string. Right. Okay, listen again. There's a small, I would say, a trick as well to identify the belonging of the tension, right? Now when we mark a tension, look at here, when we mark a tension on a string like this, one side of the arrow is an open side. This is an open side, and this side is the closed side, or that's called the vertex, right? Always tension belongs to, if you have properly marked tension belongs to the object at the open side of the mouth of the arrow, right? As an example, see, this arrow is open to A, that belongs to A. This arrow is open to string, that belongs to string. This arrow is open to string, that belongs to string. This arrow is open to B, that belongs to B, right? Right? So just know that as well. We are not going to write it, right? We are not going to write this, just know this, right? Always tension belongs to the object which is at the open side of the arrow, if you have properly marked them, right? Now come on, write this down, take this down with an asterisk mark again. When tensions are properly marked, it belongs to, the object which is, at the open side, of the arrow, right? All right. As the next heading, write down weight of an object. Next heading, weight of an object. Weight. Weight of an object. As the heading, write down weight of an object. Right. And below that, write down weight exerts due to gravity of earth. Weight exerts due to gravity of Earth. So in other words, we can also say due to gravitational field of Earth, right? Weight exerts due to gravity of Earth. See, this is something you already know. Weight can be written as mass times gravitational acceleration, right? This is something you already know. Gravitational acceleration, right? Now, mass is usually denoted by m, weight is by w, mass is by m, and gravitational acceleration is by g. So therefore, weight equals mg always. Weight equals mg, right? Take it down. Okay, just after this, we are going to start applications from Newton's laws. Right, now you are about to go with applications of Newton's laws. Repeating again, if you have any questions, any doubts, or anything to clarify up to the parts we discussed up to here, because these are the fundamental concepts you have to know about forces, Newton's laws, and marking reactions, tensions, everything before starting application. So therefore, repeating again, if you got any kind of doubts regarding anything up to here, please do ask before we are moving on to applications. Right. Okay. Is it all clear up to here? Good. Online students? Online students, what about you? Is it all clear up to here? Okay. All right. Okay. So as heading, write down applications of Newton's laws. Applications of Newton's laws. Applications of Newton's laws. Applications of Newton's laws. Right. So first, I'll explain this one as an example application. Take this down as first one. I'm going to explain the first one anyway, and then I'll let you do few questions. And you'll be getting the tute of Newton's laws by next week, and there we will practice more applications. Today we'll be practicing few applications. You are practicing few applications with me to get familiarized with Newton's laws, right? So once you get the tute, we'll do more applications on Newton's laws, right? So today also we'll be doing as much as possible number of applications, right? As the first one, first write this down. Two masses, 8 kg and 2 kg. Two masses, 8 kg and 2 kg. Two masses, 8 kg and 2 kg. Two masses, 8 kg and 2 kg are attached to a string, which goes over a smooth pulley, which goes over a smooth pulley. You all know what a pulley is, right? Right? So if you have seen wells, you might have seen pulleys. You know what pulleys are, right? Which goes over a smooth pulley. If the system is released at rest, if the system is released at rest, if the system is released at rest, home number one, determine acceleration of objects. Determine acceleration of objects. Determine acceleration of objects. Problem number 2. Problem number 2. Determine tension on string. Determine tension on string. Determine tension on string. Okay. Take this down. Take down the diagram first. Don't do anything. I'll explain this first one. Take down the diagram. This pulley is attached. Huh? This is the pulley and this is the bracket, the supporter bracket of the pulley. So that is attached to a ceiling. And these are the two mats as I mentioned. So they are attached to two ends of the pulley, two ends of the string which goes over the pulley. Right? Take it out. Right. So when these two are hanging, with strings will be exactly vertical. They are strings, right? They are not wires, they are strings. So strings will be exactly vertical, right? Okay, look at here. Now again, stop all your work and look at here. Now, once you get a question, once you get any sum, any application from Newton's laws, from F equals ma, as the first thing, we have to mark forces, right? We have to mark forces. When forces are marked, we call the diagram a force diagram, or it is also called a free body diagram. Both are said force diagram or free body diagram, right? So when marking forces also, first it's better to start with, and it is recommended to start marking forces with weights, right? So first mark weights, and acting direction of weight will be, it is always vertical downwards. Acting direction of weight is always vertical downwards because that is due to gravity. Earth is below. Since Earth is below, weight is towards the Earth because that is due to gravitational field of Earth, due to gravity of Earth, right? So therefore, that is always towards Earth. Towards Earth direction is a vertical downward direction. So therefore, always you will be marking, and we will be marking the weight vertical downwards only, right? Always weight will be acting vertical downwards, right? So first I'll be starting with the weights here. Weight is mg. Now m is given as 2 and g is 10. G is 10. So therefore weight of this will be 20 newtons. Weight is a force. So that is measured in newtons. That is vertical downwards 20 newtons. And here that is also vertical downwards 80 newtons, right? After marking forces, after marking weights, after marking weights, as a habit, check whether this string is going to be stretched or released. Because if there's a string that is going to be released, in any case, there won't be a tension in the string, right? If the string is stretched only, tension forces exert, right? Now, this is like this. How many strings are here? How many strings in this scenario? 2, 1. Online students, how many strings are here? How many strings are here? How many strings are here? Common sense. You don't have wells in your homes, right? You have the waterboard line, is it? Uh, See? Now if this is the pulley, right? This string goes over the pulley like this. And for these two ends, the masses are attached, right? So this is a single string. This is a single string which goes over the pulley, right? So therefore, only one string is here. There is only one string here. This is the same string which goes over the pulley and come into this side. Same string, right? Now, look at the board again. If you think of these two forces, this 80 newtons acting at this end of the string downwards, and this 20 newtons acting at this end of the string, right? Now, if you can't think this way, you can stretch this and think. String at this end we have 80 newtons. At this end we have 20 newtons. This is the same string. Now, if you think of this string like this, if you stretch this string like this 80 newtons is to this side, 20 to opposite side. Now, actually these two are acting in opposite directions. Even though it looks like the same direction, they are actually opposite, right? So, if you can't see it here, you can straight this string like this and see. Is it clear? Yes. Is it clear? 80 newtons to here and 20 to here, which means they are actually acting along the opposite directions of the string. Opposite directions means due to opposite forces, due to repulsive forces, string will be stretched, right? String will be stretched. මේ වගේ forces දෙකක් දැන් තියෙන්නේ. It will be stretched, right? මේක තමයි මේ පුලිය එකේ දෙපැත්තට ගිහින් තියෙන්නේ මෙහෙම. Clear? Right? This is what is at five sides of the pulley. So therefore, due to this stretch, there will be tensions, right? So likewise, knowing whether there are tensions or not, mark them. Now, as I told you, we are marking tensions on objects only. Tensions on objects only, right? There will be one tension on 8 kg, let's say T, right? So if there is the same string, tensions are same. That also I told you. If the string is weightless and inelastic, tension will be same, right? And this is another object. Pulley is also an object, right? So there will be a tension on that pulley as well. That is here like this, right? And this side also we have a tension, and here also we have a tension which belongs to this, right? This is how tensions are marked. This is how tensions are marked. And once these tensions are marked, you should be very clear, 100% clear about to which object these tensions belong to. So like this T belongs to T, 8 kg, right? This T belongs to pulley. This T belongs to pulley, open side of the mouth. This T belongs to 2 kg. So likewise, you should be able to recognize to which object these tensions belong to, right? Okay, complete marking forces here. Don't do anything other than marking forces. Even if you know how to calculate acceleration, don't do, because I'll be explaining this from the very scratch. And don't worry, I'll be giving you the chance to do these questions after this one onwards, right? One, yes. Okay, finished? Look at here. Now, we have to identify the moving direction. Now, if all forces are marked, right? First step when you deal with Newton's laws is force diagram. Force diagram means we have to mark all forces, right? If all forces are marked, then the next step is we have to identify moving directions. Now, this is like from this 80 newtons, this string is pulling to the downward direction. And from this 20 newtons, this is also pulling to the downward direction. But from 80 and 20, 80 is heavier. So therefore, 80 will win this battle. So the direction of motion of this string will be towards 80, because this side is greater, this side is heavier, right? So motion is like this. If the acceleration of 80 newtons is downwards, right? Acceleration of 2 kilograms will be upwards like this. right? So likewise, the second step is you have to identify the moving directions. You have to identify the moving directions. Understood? Right. Mark them. Mark them. Finished. Okay. Now we are good to go with the application of F equals ma. See, look at here. Look at here. When we use F equals ma, first you have to select an object that you are going to use F equals ma. Right? Now let's say first I'm going to use 8 kg. You have to mention this like this. Now, there are multiple objects, so we have to mention this. Like for 8 kg, right? And we have to mention the direction. F equals ma is a vector equation, right? Vector equation. So therefore, we can apply this equation only along a considered direction, right? So we have to mention that considered direction. And since there is a vector equation, all basic rules regarding vectors are valid here as well, right? And we have started our discussion on vectors and basic rules of vectors way back in linear motion, right? So if I quickly recall what basic rules of vectors are, first one, vectors acting to the considered direction are considered as plus, and vectors acting to the opposite direction of considered direction are considered as minus. And if we have inclined vectors, we have to dissolve them into components that we discussed in projectile motion. And if you have perpendicular vectors to considered direction, they will be neglected, right? Those are the four basic rules regarding vectors, right? All four are valid here as well because F equals ma is a vector equation, right? So first thing is you have to have a considered direction, and always as a practice, when you apply F equals ma, apply F equals ma along the moving direction of object, right? Now 8 kg is moving downwards, apply downwards F equals ma, right? Now we have to identify these force frames we are using for 8 kg, right? Now identify these forces. Tell me, 80 newtons belongs to no. From objects, tell me, 80 belongs to which object? 8 kg, 2 kg or pulley or string. There are 4 objects in this system. 80 newtons belongs to 8 kg. This T belongs to 8 kg. So which means this is the force frame. This is called a force frame. So this is also called a reference frame, right? This is the force frame of 8 kg, right? මේක ඇතුලේ තියෙන්නේ මේ 8 kg ගේ forces ටික. And this is the force frame of 2 kg. This is the force frame of pulley that we don't need for the calculation. That is the force frame of pulley, right? Now, if I'm using F equals ma downwards for 8 kg, now in this side we have to substitute forces, no? So you have to substitute all the forces, right? 80 newtons is acting downwards. My considered direction is also downwards. So therefore 80 newtons is plus 80, right? That is plus. But T is acting in the opposite direction. My considered direction is downwards, T is opposite to that considered direction. So opposite directional vectors are considered as negative vectors or minus vectors. So therefore this is minus T, right? M, mass of the object is 8 and acceleration is A, right? 80 minus T equals 8A. I will consider this as equation 1, right? Now similarly, before that, tell me, how many unknown variables are here? How many unknown variables? 2. Then what's the minimum number of equations we need to solve 2 unknown variables? 2, right? Simultaneous equations, right? In Euler's also, from Euler's also, you know that idea. If you have 2 unknown variables as x and y, minimum number of equations you need is 2 as 2 simultaneous equations. If you have 3 terms as x, y, z, you need minimum 3 equations to solve x, y, z, right? Now here 2 unknown variables t and a, which means I need at least another equation to solve this. I'll be taking that equation from 2 kilograms. Then similarly, for 2 kilograms, moving direction of 2 is upwards, F equals ma, right? Now T is acting upwards on 2 kg, right? So that is to my considered direction, that's plus T in that scenario. But when T is to opposite direction, that is minus 20. equals m is 2a. I'll consider this as equation 2. Right? Now, you have two simultaneous equations with two unknown variables, which means you can simplify these two as two simultaneous equations and determine a and t. I have asked in a particular order as to determine acceleration first and then tension. So you have to find them in the same order when I have given when the questions are given in an order, right? Always you have to follow that order. Tension එක හොයලා acceleration වන්න බෑ. If acceleration is asked first, you have to find the acceleration first, right? Okay, so after this point, I'll let you simplify this. So you can simplify and tell me what A is. Right, and if you have any questions, any doubts regarding this application that we discussed here, you can ask anything and clarify whatever the ones you have. One, 8, yeah, good. Okay. Okay, simplify this and tell me what acceleration of this system is. If you are not there for vectors and projectile motion and linear motion, the parts we discussed during the last month, right? There are a few links of vectors and other things with Newton's laws, right? But you can grab everything from here as well, right? So until you are covering the mesh parts. So with my explanations, try to get the maximum and always try to question me if you didn't get anything, right? So as a practice, you can question me if you didn't get anything. Okay, are you all good? Acceleration equals 6. One says, is it 6? You got 10. Didn't do. Why? Simplify it. One says 6. Another one says 10. 10 again. Sir, can you explain the second equation deriving? Look at here, second equation deriving. Now I have used F equals ma upwards for 2 kg. Upwards is because the moving direction of 2 kg is upwards, right? Then if my considered direction is upwards, all upward vectors will be considered as positive, right? So this is upwards, t is positive then. But 20 is downwards, that's the opposite direction. Opposite directional vectors are considered as negative vectors. So that is minus 20. Mass is 2 and acceleration is same as a. So t minus 20 equals 2a. That is how t minus 20 becomes 2a. 6. A equals 6 and T equals 32. Why do you get different answers? Some of you say it's 10 and some of you say 6. I'll start in another minute. I'll start in a minute. So others, what about you? What about your answers? Others, what about your answers? I mean calculation. You are adding equations? Adding, eh? Then 80 plus. Okay. Yeah. Other answers? A equals 60 equals 32. Very good, very good. 6 and 32. 6 and 32. Good. Okay, good. That's good to see that you are getting answers. Very good. Right, we are still in the first question, right? As usual, we are starting from the simple question, simplest actually. This is the simplest question we'll discuss, and step by step we are moving towards the advanced questions, right? So when we move towards the advanced questions also, if you understood everything from the fundamentals from the beginning, right? Definitely you will tackle, you will go through all the questions without any hassle, right? It's guaranteed. The only thing is you have to know the fundamentals, basics here properly. That's it, right? Okay, I'll also start. See, first observe these two equations. Now, before doing anything, first observe equations. In first equation, I have a minus t. In second equation, I have a plus t, right? Coefficients are equal, which means if I add these two, minus t to plus t cancels. So with that intention, I'm going to add these two, right? So likewise, just look at the equation and think of what you are going to do and then do it. Otherwise, don't be like robots and machines and add always or subtract always. That is not going to work out always, right? There will be different cases. You have to observe the equation first. I mean, that's a better approach and that's a safe approach. So you have to observe and then do something with the thinking, right? So minus t to plus t, we can cancel. So therefore, I'm going to add these two. See, 1 plus 2, 1 plus 2. Left hand sides will be 80 minus t plus from here t minus 20. Right hand sides will be 8a plus 2a, right? Minus t to plus t cancels. 80 minus 20 is 60. 60 equals 8a plus 10a again, 2a again 10a, right? 0 to 0 cancels. A equals 6. And this is an acceleration, ms minus 2. It's a must to put units if you got the final answer as a number, as a numerical value, right? But if you get the final answer as a label, right? So you know from linear motion and projectile motion also, same thing applies. If you got this answer as a label, MO, capital M, simple M, something like that, then no need to put units. But if you got the final answer as a number, as a numerical value, it's a must to put units, right? Okay. Now if A is known, you can use either of the equations to determine T. I'll be going with second one from 2. From 2, we know T minus 20 equals 2A, which means T equals 2A plus 20, right? And 2, A is 6 plus 20. Simplify this. 12 plus 20, T is 32 newtons. That's a force that comes in newtons. T is 32 newtons. T is 32 newtons. Right? Yeah, so most of you got the answers. Very good. Good. Very good. Okay. Any questions from this? Yeah. Any questions from this? Any questions from this? Or is it all clear? Tell me whether it's clear, or if you have any doubts, you can ask the doubts. And if it's clear, if you understood this, tell me whether you understood. Yeah. Online students? Okay. Clear. So can we get time for pray? Sorry. 6:11. Yeah, I'll give you 5 minutes. Yeah. So after this question, I'll give you this way. Yeah, before 6:30. Is it? You have to pray before 6:30. Yeah, I'll give you. Understood. All right. All right. Okay. After the question, put an asterisk mark in red and write these points down. Take these points down. First point, apply F equals MA. Apply F equals MA. Apply F equals MA along. Apply F equals MA along direction of motion of objects. Apply F equals MA along direction of motion of objects. Apply F equals MA along direction of motion of objects. Apply F equals MA along direction of motion of objects. Second point, all basic rules regarding vectors, all basic rules regarding vectors, all basic rules regarding vectors, all basic rules regarding vectors should be followed. All basic rules regarding vectors should be followed since F equals MA is a vector equation. 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 Okay. Right. So before moving on to the next question, now it's 6:13. I'll give you 5 minutes to go pray and come back. So this is 6:13. I'll be starting back at 6:18. So make sure that you are back at the class at 6:18 by 6:18. Right? Okay. Now you can go and come. Can you please repeat the first point? What is it? Apply F equals MA along direction of motion of objects. Apply F equals MA along direction of motion of objects. Right. You can go and come by 6:18. Right. If you have any questions, you can ask and get. So if there are anyone who don't pray, maybe non-Muslim students, if you are in the class, I'm still here. So you can ask any questions if you have and get it clarified. Right? And we will be starting at 6:18. Yeah, if there are any questions, you can ask. Huh? Is it done? All right. So hope all of you are back. Right, online students. Hope all of you are back. Let's move on to the second one. Question 2. Question 2. Right. Okay. Take this down. Take this down. Question 2. Label these two objects as A and B. Label these two objects as A and B. This is a horizontal table. This is a horizontal table. And this pulley is fixed to the edge of the table like this, right? These two objects are attached to the string which goes over this pulley, right? Understandable? Okay. Take it down. I'll give you the question. Take it down. Right. Okay. Write down the question. Write down the question. Two objects A and B. Two objects A and B. Two objects A and B. Two objects A and B of masses 2 kg and 3 kg respectively, of masses 2 kg and 3 kg respectively, 2 kg and 3 kg respectively, are attached to a string which goes over a smooth pulley, All surfaces are smooth. All surfaces are smooth. All surfaces are smooth. All surfaces are smooth. If the system is released at rest, determine acceleration of objects, and tension of string, Okay. Now I will give you to try. I will give you some time to try first, and then I'm going to start. So recalling again, first mark all forces, and from forces also first try to mark weights, and then by checking whether the string is actually stretched or not, mark tensions, right? Then think about the moving directions, and then apply F equals ma by clearly identifying the belonging objects of forces, right? Okay, give it a try. And listen all, as I told you before at the start of the class, beginning of the class, today I'll be continuing the class until like 6:57, because we had a delayed start today, right? So you all know that, no? We had a delayed start today due to some technical issues of the camera, right? So therefore, for online students also, just be aware that we'll be continuing until 6:50, right? Because I need to cover everything that I was planning to cover today in this seminar, right? Now we are like 90% covered, right? But we'll discuss everything that I plan to cover and we'll finish, right? So please stay in the class, because today is going to be like directly connected with the second day we are going to have, right? So you also have that courage to learn. So as I have this courage to teach, right? So if you have any questions, you can ask. Sorry. Okay, first let's see the force diagram. Right. What's weights? Weight of 2 will be 20 newtons acting vertically downwards. Right. Weight of 3 kg will be 30 newtons acting vertically downwards. Right. And here there's a reaction as well. So if you need, you can mark the reaction. Right. Now you can assume this is a contact between box and a surface. So the common surface is here. Right. Reaction by flow on object B is upwards. That's a reaction. Right. There is an equal and opposite reaction on flow, but I'm not going to mark it on the flow because we are not going to use the equation F equals ma for flow. Therefore, no point of marking it. Otherwise, if you have marked it, that's totally fine. But there's no point of marking. Therefore, I won't mark the reaction of R in this case, just for the time being now. Right? Okay. Then about tensions. Now, this side of this string is having 20 newtons. Right? It's having a pull of 20 newtons. If you check the other side, there is no force acting along the string on this side. No force. Because these two are not acting along the string. These two are actually perpendicular to string. These two are perpendicular to string. Along the string, direction. So there are no forces acting along the string. Only force acting along the string is 20 newtons. Right? So which means the motion is going to be along the string. Right? Motion is going to be along the string. Which means this 20 newtons is automatically heavier because there is no one to stop 20 newtons on the other side. These two are perpendicular. Perpendicular forces are not going to contribute a perpendicular direction. Right? So therefore, only force which supports the motion here in this case is 20 newtons. Right? There is no support from 30 and R for this lateral motion along the string. Right? So only force which supports the motion here is 20, which means moving direction will be towards 20. Right? So therefore, the string will be stretched because this end is attached to this, attached to the point. So when this goes down, automatically string will be stretched, which means tensions are exerted like this. Tensions are exerted. If there is a single string, same tension occurs. Right? And now moving directions are, this side is heavier, so it goes down. A. When this goes down, this comes to right. So this moving direction is, mark all moving directions before applying F equals ma to the right. Right? So these are the moving directions. Now, after marking all these things, now you are good to proceed with the application of F equals ma. Right? Make sure to mention to which object you are using the equation with the direction. Right? Because they are vector equations. Give it a try. And if anyone of you get answers, right? If anyone of you get answers, you can say me, or if you can, if you are an online student, you can put that to the chat. Yeah, what are the answers? Now, if you have got any answers, we need acceleration and tension again. And reminding again, the class will be shifted to Friday next week onwards, right? As I told you. it will be shifted to Friday from 3:30 to 6:30, and you will be getting an official message from the institute as well, and you will be getting messages from my side as well. So please make sure that you are in the group, because I'll be giving all updates to that group only, group or channel, right? Group or channel only, right? So please make sure that you are in the group, and the permanent time of the class will be Friday from 3:30 to 6:30 next week onwards until your A-level exams, right? So due to some reasons regarding chemistry classes, we had to shift from Wednesday to Friday. That's the reason. That's the actual reason. That is not my personal reason, right? I also had to change 2 other classes that I had on Fridays due to this change. The reason was chemistry classes here in and around the institute, this area in Bambalapitiya, Ballavatta, Devara, this area, all chemistry classes for 27 batch are on Wednesdays. So therefore, since there's a conflict between the subjects, now I had to switch this class to, I have to switch the day to Friday. That's the reason. That's the reason. Right? Any answers? Anyone? Are there any answers? A equals 2 and T equals 26, one says. What about others? One says A equals 2 and T equals 26. You got the same? You got 10. 10, both of you. Okay, another one says A equals 10 and T equals T? Didn't determine it. Okay. Others? What about you? Others? What about the ones on YouTube? Yeah, I can see you are also engaging actively. Very good. Very good. Since this was conducted as a free seminar, this video will be available on YouTube after the class as well. So therefore, if you need to go through the session again, if any one of you need to go through the session again, if you need to recall the things again by going through the session, you can visit my YouTube channel and you can find this class recording. Right? Yeah. Any changes or is it same? 10? No, 6. Tension is 60. Acceleration is 10. Okay. Let's see. What about others? What about others? Okay, let me start. Now, there are a few things from vectors here as well, right? Let me start. Now, for 2 kg first. See, for 2 kg first. Moving direction is vertical downwards, right? Downwards, F equals ma. Downwards, I have 20. And T is upwards, that is opposite to my considered direction. That becomes minus T, right? And mass of that object is 2 and the acceleration is a. So my equation 1 is 20 minus T equals 2a, right? To get the second equation, I'm going to use 3 kg, right? Then for 3 kg, moving direction is horizontally rightwards. F equals ma, right? There are 3 forces which belongs to 3 kg, right? But from vectors we know that perpendicular forces or perpendicular vectors to consider direction will be neglected. Perpendicular vectors to consider direction will be neglected. Now, for my considered direction, both R and 30 are perpendicular. So they won't be considered. They are neglected forces. And only T remains. Right? That learning is coming from vectors and the previous parts we discussed. If you didn't know it, just know now that if there are perpendicular vectors to your considered direction, they will be neglected from the calculation, right? They will be neglected from the calculation. We discussed it with the reasons in vectors. Right now, only force remaining in my considered direction is t, that is plus t. So only t remains. M is 3a. This is my second equation. T equals 3a. Right? Now, again, we can add the equations because minus t and plus t is there. I can add the equations. I'll be adding 1 and 2, 1 plus 2. From left hand side, 20 minus t plus t. Right hand side, 2a plus 5a. T to t cancels. 20 equals 5 minutes 3. 20 equals 3a, 5a. 20 equals 5a, and a is 4ms minus 2. I think I didn't see 4 from any one of you, right? You said 10. In the online chat also, I didn't see 4. Eh? No, I didn't see 4. You said 10 and 6. Eh? Right? So, vector rules, basic rules regarding vectors rules, right? A equals 4. If A is known, now we can determine tension. Now, easiest equation to determine tension is second because T is already subjected, right? So, using second equation from 2, we can determine T equals 3A. So, T equals 3 times 4, T equals 12 newtons. T equals 12 newtons, right? Simple as that. What are the mistakes you made? To get 10, what was the mistake you made? You considered 30 here. Same. 30 newtons weight will be neglected because that's a perpendicular direction to my considered direction. If I use the equation vertically, 30 nr is coming, right? But otherwise, when you are using the equation horizontally, that is not coming because they are perpendicular directions, right? No point of using the equation vertically because there is no acceleration vertically. Acceleration is only to the right, right? If there is no motion vertically, there is no acceleration vertically, right? If we apply F equals ma vertically, what we get is R. See this? Something additional. Something additional. I didn't ask this in the question, but you better take this down as well. Now, if I need to determine R, let's say, what we do is, again, for 3 kg, we can use F equals ma vertically. It's a vertically upwards. Now, T is not coming, but R and 30 are coming. Then this becomes R minus 30. R minus 30 equals M is 3, but this is very important. There is no vertical acceleration for the object. Even though the acceleration is here, non-zero acceleration is here, horizontally, there is no vertical acceleration. Right? If there is no motion, there is no vertical acceleration, which means that is 0. Simplify this, which means R minus 30 equals 0, R equals 30 newtons, right? Now, if I need to get the reaction, that is how the reaction is determined. This is actually called an equilibrium. And about these equilibrium parts, we will be discussing on the next day. Now, I explained this today because some of you were mistaken. 30 with this applied direction, right? 30 is a vertical force, right? 30 එක consider කරන direction එක ගත්තොත් R හොයා ගන්න වගේ තමයි පුළුවන්, right? So you can take this down too. This is how the reaction is determined, right? This is how the reaction is determined. Okay, any other questions? Any other questions? All good? Clear? Yeah. Online students? Understood? What about you? Online students? All clear. Right. So after the question, mention this point in red. Mention this point in red. Mention this point in red. Since 30 newtons and capital R. Since 30 newtons and capital R. Since 30 newtons and capital R. Since 30 newtons and capital R are perpendicular to direction of motion, They are neglected. They are neglected when F equals ma is used horizontally. They are neglected when F equals ma is used horizontally. They are neglected when F equals ma is used horizontally. They are neglected when F equals ma is used horizontally. Okay. Clear? Question 3. Question 3. Question 3. Take this down. Take this down first, then I'll give you the question. First, take down the diagram. Let's take down the diagram. A, B, and C. Right, 4 kg, 1 kg, and 1 kg. Right, 4 kg, 1 kg, and 1 kg. Okay, write down the question. Write down the question. Before writing down, tell me how many strings are here. Think and tell me how many strings are here. How many objects are here? Objects in the sense the connected objects. How many connected objects are here? 3, A, B, C. Right? So how many strings? Now we have 2 strings. Now we have 2 strings. Right? Now we have 2 strings. Because strings are not going through objects. Huh? A string should be connected to an object from its sides like this. The strings are connected with a knot. Right? Get a right? In reality, strings are connected with a knot. Right? It is attached with a knot. Right? මෙහෙම string එකක් තියෙනවා මේ single string එකේ තියෙන්න බෑ. This cannot be a single string because it doesn't go through. Right? Definitely there should be 2 strings. Okay, write down the question. 3 objects A, B, C. 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 3 objects A, B, C of masses 4 kilograms, 1 kilogram, and 1 kilogram respectively. Are connected using 2 ideal strings. Are connected using 2 ideal strings. Are connected using 2 ideal strings. 2 ideal strings. Are connected using 2 ideal strings, which goes over 2 smooth pulleys as shown. 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 If the system is released at rest, 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 determine determine, put a comma and take down the parts as 1 and 2. Determine, put a comma, and part 1, acceleration of objects. Part 1, acceleration of objects. Right. Part 2, tensions of strings. Tensions of strings. How many tensions you need to determine now? 2 tensions will be there, right? If there are different strings, different tensions will be there. So I'll be helping you with marking tensions here, right? For the same string, same tension. But if that's a different string, then from string to string, tensions will be different. From string to string, right? Through the same string, tensions are same, right? So second one is tensions of strings. Tensions of strings. Okay. Yeah, 2 minutes. Mark forces and consider tensions. When you get different tensions, consider them as T1 and T2 and mark it. I'll be helping you with marking. So before I mark, I'm giving you 2 minutes to mark it. Mark all forces. Mark all forces. Mark all forces. Mark all forces. These parts that we are going to stop today, I mean, these parts we have discussed, and the point we are going to stop today will be directly connected to the point we are going to start on the next day, right? So therefore, now after the class also, now since it is a free seminar, as I told you, this recording is available on YouTube. So at any time, if you need, you can go back to that and watch it if needed, or else without watching it, if you are comfortable, you can try out these questions I discussed in the class again and again, like 2-3 times, and come to the next class, because we'll be starting from the point we stop here on the next day. I scratch next day chance, right? So since now we are stopping somewhere here, right? You should be comfortable with what we have discussed up to this point. Now you know. Now I know there are some students. Now you are doing all the questions faster, and you are approaching the questions quickly today. But after 7 days again, after 7 days when we are meeting again, you can't recall anything. You have forgotten everything, right? No, that is not going to work. That's why, right? So that's why I'm always emphasizing. So go through these things again and again, and be comfortable with this before coming to the next class, right? So in the next class, we are going to discuss the advanced questions of F equals mc Newton's laws, right? These are not the average even. These are the easy questions, simple questions, right? Next day we will be starting with average ones, and we are going to end the day after the discussion of all advanced questions as well, right? There are some other different types coming up, right? So today, after this seminar, now you know all the fundamentals, the fundamental concepts behind F equals ma, and in all equations, all applications, what we do is we are choosing a direction and we are using F equals ma, right? So when we are moving up also, applications will be different, like with number of objects, number of strings, and everything, right? And the cases are with weighted strings, and there are cases with different accelerations. Now still we have only same acceleration. For all 3 objects, accelerations are same. There are cases where the accelerations are different from object to object. There are instances. So those are the advanced questions in Newton's laws, right? So we'll be discussing everything next day, and going to finish off Newton's laws, these parts of Newton's laws, by the next day. And the next lesson will be starting after Newton's laws will be linear momentum, right? Right. So there are a few other types of questions in Newton's laws. To complete everything in Newton's laws, it will take around like another 2 days, right? So we'll be finishing Newton's laws. So that's the gravity. Yeah, that's a gravity. Different accelerations. It was a reactions determination. That is the internal reaction determination. When we have object in contact, we can determine internal reactions of them using F equals M. There are different use cases, applications of F equals MA, and those are the parts which are coming up in the other parts in Newton's laws, right? Marking forces. Starting with weights, 40 newtons here, right? 10 newtons here and 10 newtons here, right? And only two forces which contributes the motion here is 40 and 10, because this is perpendicular to the string. Direction of motion of the system is going to be along the string only, because they are going through pulleys, going over pulleys, right? So therefore, these two contribute the motion. From these two, 40 is heavier, right? If you can't see it like this, assume that you are going to take this straight. Then along this side you have 10 newtons, along that side you have 40. 40 is greater, 40 is heavier. So the motion is going to be towards this side. So the string will be stretched. Now there are two strings. See, one string starts from here. Look at here. One string, first string starts from here and it goes over this first pulley and ends here, right? The second string starts from here and it goes over this pulley and ends here, right? Two strings. I'll be marking the tensions as T1 and T2, right? T1, T1. And here, that's a new string, a second string, T2, T2. Along the same string, tensions are same. But if the string is different, tensions will be different. This is the force diagram. This is the force diagram. This is the expected force diagram. This is the correct force diagram. So check your force diagram with mine, and if it is correct, now you can start the application and determine. There are three terms now. Determine acceleration, T1 and T2. Acceleration and two tensions. Anyone who has got answers? Now, how many unknown variables before you start? How many unknown variables here before you start? There are three unknown variables, A, T1 and T2. Then minimum number of equations you need is also 3, right? Equations 3 ඕනේ වෙනවා කොහොමද? ඒ තුන අරගෙන simplify කරන්න. A equals 6. Let's see. A equals 6. That is correct. Very good. Good. T16. Okay, good. Yeah, Mahadi, why you are joining online today? You didn't inform me anything, right? Is there any particular reason? All right. So if there's anything, you can always contact me after the class even. I mean, for subject matters, anything like that, you can contact me after the class even. I hope you have got my number. And since this is an open seminar, I'll give you the number as well, right? From the YouTube live also, you can find it out. For any clarifications needed regarding anything, you can contact me to this number 071 618. Let me check again. 618-859. Yeah. So you can contact me through this number if you have any doubts or for any clarifications, inquiries. You can contact me directly through this number. If you need to contact the institute, you can call the hotline number, right? And this is my personal number, right? Regarding anything, if you need clarifications, even if you are a student who is not attending to the classes usually, but you are there in this free seminar, that doesn't matter. If you have any clarifications, if you need something to know, don't call. Please feel free to drop me a WhatsApp message to this number, right? So definitely I'll reply if I'm not in a class. Okay, any other answers? Yeah, only one got the answers yet. And you said t equals 16. There are two t's that I didn't see. You said t equals 16 here. There are two t's. So I need t1 and t2 separately. So check that again in your simplification. There are two t's. What about you? Show me the equations. 40, correct. No, this is perpendicular. For the direction authority. For 1 kg can this is for the vertical 1 kg. All right. For that, T2 minus 10. You are using upwards. Using the equation upwards, then upward force is T2. Yeah, downwards, that's the opposite force. T2 minus 10. This make a 10 in there. Why? That is perpendicular. When you use horizontally, that is perpendicular, and there are two tensions are coming. Both tensions belongs to T1, T2. Both belongs to B at that point. Right? Same. This is correct. T2, isn't it T2 in your case? In your right, okay. No, just having two equations, we can't do anything because this is T1, this is T2. It is not going to cancel each other. Then you have to use a third equation. As a third equation, use B. Now, when you mention about objects, you can mention them as ABC. That's why the labeling is given without mentioning the mass. Now, if labeling is not given, we have to mention the mass. But if the labeling is given, you can just introduce them as ABC, right? For C also, sorry, for B also, you need to apply. Otherwise, there is no way to get the third equation, right? If you got any questions, any clarifications needed, feel free to contact, right? Correct. Revised. This is correct now. This should also be revised. Are you doing biomaths? That's you also you're bad. Now, if you haven't finalized the classes yet, now this is a very high time to finalize your classes. Don't wait this month. Now, by this month, finalize your classes for all 3 subjects and attend. Right now, for all subjects, I think what we call the fast track classes. So the second batch is also started, right? So therefore, without missing that again, because your results were released on 20th or something. I can't remember. Somehow we started this new batch on 22nd of July. I think before that week, results were released. 1 week later, the second batch was started. Right. So finalize your classes and you can start working this point onwards. That's not a problem, right? With respect to the start of this class, you have missed around 14 weeks. Started in April. Yeah, I think this is the 15th week of the class, the ongoing week. I guess it should be 15 or 16, right? Yes, because in other subjects also the fundamental knowledge is always required, because there's a sequence, an order in lessons when you are learning, right? There are links in physics. This is the subject with highest number of links, right? And mechanics is the unit with highest number of links, and all 11 units in physics also are linked together, right? T1 is 10, T2 is 6. And another one says A equals 6, T1 is 16, T2 6. Okay, let's see. Any answers from your side? Okay, first let's see what the equations are. What the equations are you should obtain. See, on YouTube A equals 8 and T1 equals 8. A equals 8 and T1 equals 8. A is not 8, A is actually 6, right? A is actually 6. Check the simplifications. See, now identify the moving directions. 40 side is heavier, so this goes down. This goes down, right? Then since this is attached, this object moves to the right. Sorry, left. This object moves to the left, and this is also attached. So this comes upwards. This moves upwards. These are the moving directions. These are the moving directions, right? Now you can use F equals ma. First, I will be starting with A. For A. For A, direction of motion is downwards. So we will be using F equals ma downwards, right? Downward force here is 40, and T1 is upward, which means that is opposite to my direction. So that is minus T1 equals m is 4a. 40 minus T1 equals 4a. I will consider this as equation 1, right? Then as the second equation, I'm going to use B. For B, moving direction of B is horizontally leftwards. Along that same direction, we can use F equals ma. 10 newtons is not coming because there is perpendicular, to the motion, right? Perpendicular to the motion. So 10 newtons is not coming. 10 newtons is not coming. T1, only T1 and T2 are coming. To the direction of consideration, I have T1, so that is positive. Opposite direction, we have T2, that is minus T2. M is 1. 1 into A. 1 into A is A. So which means T1 minus T2 equals A. I'll consider this as equation 2. Right? Then for C, moving direction is upwards. So you can use F equals ma upwards. F equals ma upwards. Right? Upward force is T2 here. So that is the positive force. And 10 is downwards. That is opposite to my considered direction. That is minus 10. That becomes minus 10. 1 times A again. So this is T2 minus 10 equals A. That is equation 3. These three are the three equations you should get if your application is correct. If your application is correct, these three are the three equations you should get. Okay, now if you have get these three equations, now these are three simultaneous equations. Simplify them as three simultaneous equations and find A first and then T1 and T2. So I told you, observe first whether your addition or if you are adding equations, your subtraction is going to work here actually, and proceed. Otherwise, don't be like robots and add equations always. Observe all three equations properly. Observe all three equations and do something with that thinking, with that understanding. That is very important. That is very much important. right? See, now in this first equation we have minus T1. Second equation I have plus T1. Right? Adding, I'm checking again. In the second equation I have minus T2. Third one I have plus T2. Right? Then what's the easiest thing to do? If 2 and 3 are added, T2 is going to cancel. Then now you should understand what's the easiest thing to do here. We can add all three at once. Simultaneous equations, we can add all three at once. Right? Simple maths. Simple maths. We can add all three at once. This is the shortest way. 1 plus 2 plus 3. Now, if you add 2 by 2, simplification is lengthier. Still, you can simplify. Yet, you can simplify, but very lengthier. Right? 1 plus 2 plus 3. See, now left hand sides are added together. 40 minus T1 from second equation plus T1 minus T2 from third equation plus T2 minus 10 equals from right hand sides 4a plus a plus a. Right? 4a plus a plus a. Now you can see minus T1 to this is wrong. T1 minus T2. Second equation T1 minus T2. T1 minus T2. Right. Minus T1 to plus T1 cancels. Minus T2 to plus T2 cancels. Right. Now all tensions are omitted. 40 minus 10 remains. That is 30. Right. 30 equals 4a plus a plus a කියලා කියන්නේ 6a. Right. A is 30 over 6. 30 over 6. That is 5 ms minus 2. That is 5 ms minus 2. You said 6 nail. 6 is wrong. 6 is wrong. It's 5. It's 5. You said 6, ne? I saw 2 or 3 students say it's 6. It's actually 5. It's actually 5. Right? It's 5. This is the calculation. You can check your simplifications again. You have to. You can check your simplifications again. You have to check your simplifications again. Okay. Now, if A is known, to get T1, I'll be using equation 1. See, from 1, 40 minus T1 equals 4a. 40 minus T1 equals 4a. A is 5. Right? Which means 40 minus T1 equals 20. Subject T1, T1 equals 20 newtons. T1 equals 20 newtons. Right? I'll be using 2 for the second answer. From 2, T1 minus T2 equals A. T1 minus T2 equals A. Right? So which means T1 is 20 now. 20 minus T2 equals 5. Right? So T2 is 15. T2 is 15. Right? So probably I think all of you have made simplification errors. So there are two probable reasons. One will be if you have marked tensions as same, that is going to be totally different. If you mark tensions as same, that is going to be totally different. And the other obvious possibility is you can make a simplification mistake. Right? So these are the correct answers, final answers. Acceleration is 5, T1 20, T2 15. Right? So likewise, now we are gradually moving towards the advanced questions. Right? Okay, any questions from this? Any questions? Anything to clarify? Any questions from this? Oh, good, understood? Online students? Online students, what about you? Understood? Or if there are any questions, you can ask me now. Clear, right? So if you have made mistakes, you should understand your mistake, because understanding your mistake is the learning you have. Then in the next question, you won't do that same mistake again. Understood? Understood. Okay, good, good, very good. All right. Okay, now today, as we planned in this seminar, now we started Newton's laws and we finished all theories. All theories are done now. All theories we finished, and this is the third question we discussed. So we have discussed 3 questions so far, right? And next day plan is we will be moving forward beyond this point with other average questions and advanced questions, right? And if time permits, on next day itself, we will be starting internal reactions on objects, right? Internal reactions on objects as well, right? Okay, so that's the thing. And when you are coming to the next class, as I told you, please go through these parts again and again and get yourself familiar with this what we do, with these things what we do, because when we are moving forward with advanced types of questions, now here also this is not an advanced question, this is like this is close to average. I mean, 3 equations, right? There are cases with 4 simultaneous equations as well, right? Up to 4 in a cases there, right? 5 නම් එන්නේ නැහැ A level physics වලට, 7 විතර එනවා maths කරනවා. සාමාන්‍ය 7 8 simultaneous equations කියලා කියන්නේ normal in maths. In maths it's normal. අමාරු නෑ, it's very easy to simplify, but getting around 7 8 simultaneous equations are very normal in maths. Here නම් maximum 4 equations වගේ තමයි එන්නේ, right? 4 කියලා කියන්නේ it's very rare. 4 එකත් rare. 3 නම් usually come in, right? 2 and 3 very usually come in. නැත්නම් maximum આવත් වෙන්නේ 4 එහෙම ආපු cases තියෙනවා. maximum આવත් වෙන්නේ 4, not more than 4, right? 4 આવත් ඉතින් මේ වගේම තමයි මේ ඔක්කොම add කරපු ගමන් ගොඩක් වෙලාවට cancel වෙලා යනවා. අර ටක් ගාලා එහෙම වගන්න පුළුවන්, right? Okay, so then please go through these things again and again, and it's better if you can do these questions again after 2-3 days. Now today is Wednesday, by like Saturday Sunday, okay, just try it out again and check whether it's doable by your own, right? Now if you stuck again, you can come to the note again and see where you have stuck, right? So likewise, familiarize yourself with these things, because now for coming 2 to 3 days, you will be with Newton's laws during this month, right? So there are a lot to do, right? There's a depth that you didn't see yet in Newton's laws, right? So there are more things. So therefore, please go through and come again. Otherwise, now when I explain the questions in the next class, if you feel like I'm talking in Greek, that is totally because of you haven't prepared these things again and again. That's the reason, right? So therefore, please go through and come back, right? So I'll be stopping the class here, right? All right, then study hard, and physical students, you can go safe, stay safe. Goodbye and good night. See you all in the next class, right? Goodbye.